had it over, you just never pressed it.
Son of a... I just explained all that for nothing. Oh well, Matten's gonna figure out when we come back. And rebuff. Alright. Sorry, Matten. I did forgot to plus the play. But anyway, this is the stream. I'm just gonna go in really fast. Basically, the definition integral, break it down to right endpoint approximation is definition integral, and the quick breakdown is delta x equal to b minus a over n. Because we're doing f of x between 0 to 2, so it'll be 2 minus 0. Two minus 0 over n. Then it's gonna be 2 over n, which is delta x, which is each rectangle width. Now, I is a series of number from 1 to infinite. That's okay, I can explain everybody here. Basically, we're gonna use this definitions here, which is right endpoint integral, definition of integrals. Use a plus I delta x. Now, what happened is I'm gonna plug in 0 into here for a, and I, which is each number that is designed from 1 to infinite. And 2 over n is each change. Because if you increase by one rectangle, you have to have some type of change that goes in for each rectangle. So n is going to approach the infinite amount. So that each width is going to change into the function. You're going to put into the function. Therefore, it's 2i over n times 2i, 2 over n. And I plug in to the function, it'll be 2i squared over n over 2 over n. I take out as many constants as I can possibly think about, which is n to the q, and also 2 times 4, which is 8. So far, do you guys have any question? Austin, Jared, Daniel, is all good? Okay, now we just do the last easy part. The easy part is limit n approach infinity, which is if you n approach infinity, that you kind of look at just the highest degrees. In this case, it's going to be n, and I'm going to distribute that n times n plus 1 times 2n plus 1 part. So that's going to be n plus n squared n times 2n plus 1. And that's going to be 2n to the q plus n squared plus 2n squared plus n. So it'll be 2n to the cube plus 3n squared plus n over 6 to the n to the cube. Now, if n go to infinite, I'm going to take an extra step. This is not n approach infinity. So that is going to be 16n to the 3 plus 24n squared plus 8n all over 6n to the third. You know, if you divide it by highest degree on the denominator, it's going to be n to the cube. And if you do that, pretty much all the term is going to go to 0. Does that make sense? I divided by everything by n to the cube, n to the cube, n to the cube, n to the cube. Pretty much this is going to go to 0, will be 16 over 6, which is equal to 8 over 3, which is, we also know integration of x squared dx between 0 to 2, that is going to give you what? x3 over 3 between 2 to 0, so that's going to be 2 to the third over 3 minus 0 over 3, which is equal to 8 over 3. So we just find it using definition of integral.
You get all those identities out there. I squared, the IQ.
This is the one I give it to you, the summations.
Can you prove it? Or?
Well, I can prove, I cannot prove it, no. Those are just definition from summations. And other mathematician did prove it, but I just don't know how to prove it. So I rather say I don't know rather than saying I do know. But you can look it up. They actually have a proof of it. And actually, proof of this data is actually in the located Appendix A. So if you look at here, if you are interested, you're more welcome to take a picture of it. I don't know. Huh? What'd you say?
Can you zoom in on that?
Yeah, sure. Appendix A.
This is 2n plus I'm even there for one. Yeah, well. It's either green now. Huh. But I see all of them. Yeah. Yeah, I think we're being short. Yeah. But that's odd. The iterative power rule. Yep,
Yeah.
pretty much.
They didn't even put on this textbook. It's on the video. But they say proving a select theorem. Oh, let me look. Complex number. Oh, it's all online. And prove a select theorem in video lesson. I don't know. It doesn't have it right here.
So I don't remember.
Okay, so that you're gonna get A over 3. So eventually this is what gonna lead to A over 3. And I'm sorry, man, I didn't record from the beginning. Hopefully you have a good trip in Military Academy. So we're gonna do the same thing. Luckily, we're gonna do the same thing, but we're gonna do the same thing with left endpoint. So left endpoint and right endpoint, the big difference is the I right here. This is I times delta x. Now, the way you calculate the first rectangle, it's gonna be kind of crucial. Because if I were to use right endpoint like this one here, we use this, that just say it's 0, 1, and 2. We use 1, right? Which is that's a natural number. But if I were to use left endpoint, which is gonna be here, what would I be using though? Right? What would be using if I use this to find out the information? So instead of I, what should I use? If I base on the left end. So this is a definition of integral, but it's based on the right end. What would be left end? How would that I change? What do you think, Jared?
It's shorter.
Yeah, but how do you change the I to where it's gonna be from the left endpoint?
We use one for the right end.
We use 1 because that's I. We start with n I equal to 1.
So start.
Yeah, but how would I organize where that I is going to start at 0?
Like I equals 0.
No,
I minus 1 or something.
I minus 1. If you do I equal to 0, you can, but your lower bound of that, it has to be 0. No, that even that doesn't really fix it. So you can use I equal to 1 and do I minus 1. Does that make sense? So the left end, the approximation between A to B of f of x dx, dx is the delta x, is equal to limits as n approach infinity of f, sorry, that was bad, summation, which is add up all the rectangle. And we're going to start with I equal to 1 and this to the n. And it will be f of the non-capital mi. This represents left endpoints. And times by delta x. Now, with that being said, can I say is n approach infinity of delta I equal to 1, n of f. A in this case is going to be f of x is equal to x squared between 0 to 2. So that means it's 0. Does that make sense? Plus, now, it's going to be I minus 1. Why is I minus 1? Because you want to go track back, rectangle back. So your number start at 1 and it's going to start at 0, right? Let's start at 1. And then times the delta x, which is the n over 2. Sorry, this is going to be n over 2. Because that's delta x. So I'm going to experiment, use left-hand approximation. And we're going to use squeeze theorem. We didn't mention the last period. If we squeeze from the upper limit to the lower limit, we squeeze it and see if they come out exact same value. So that's why squeeze theorem is kind of important, because it apply to the calculus as well. So therefore, it's limit n approach infinity of summation I equal to 1 and f to the I minus 1 over 2 to the n over 2. Is that okay? Did I miss an n? Yeah, I did.
It was b minus a over n. So wouldn't it be 2 over n?
Did I mess up here? Yeah. Oh, yep. B minus a over n. Still too fast. So this one is 2 over n. My fault. Yes, 2 over n. So it'll be 2. Thank you. I minus 1 over n times 2 over n. Is that better? Now with that being said, I'm going to plug in the square. So I'm going to plug in the 2 I minus 1 to the n squared times 2 over n and summation of I equal to 1 and limits of n approach infinity. Now I just want you to focus on a constant. What will be a constant here?
Would you have to distribute or like expand the square?
I won't. I will just try to take it now.
4n squared? 4
No,
over n. 8 over n squared?
almost.
Oh, that's
Okay.
then
4, 8, or 3.
What? 8 over n cubed? Yeah, that's right.
I'm sorry. Yeah.
So if you do limit n approach infinity, I mean, maybe I can write it out a little bit better. And this is n here. And I can write out a little bit better. I can just say it's 2 over n to the second times I minus 1 to the square times 2 over n. And maybe that's a little bit better, because you can see that it's obviously this part, which is 4 over n squared times 2 over n. So that's going to be what? 8 over n cubed. Does that make sense? Summation of I minus 1 squared. I equal to 1. Is that okay? And to infinite, limits of n approach infinity. I can expand this, so be I squared minus 2i plus 1, right? Summation of I equal to 1, infinity of 8 over n cubed, limits as n approach infinity. Now I'm kind of gonna be cheating here, because I think I want to be lazy here, because I don't want it to. But I'm gonna write as much thing I can to be out, but I'm also gonna be lazy at the same time. I square is gonna be what is the formula for I square? It's gonna be n times n plus 1 times 2n plus 1 over 6. Does that make sense? That's I square. What is minus 2? What is the formula? N times m plus 1 over 2. Plus n. Why is n? Because 1 times n, Cn. Now, if you want to cheat, here's the best part to cheat. To understand, if I distribute everything n to the q into all the term here, what will happen to those terms when it go to infinite? For example, this one. If you distribute n to the q on all of them, I mean, I'll maybe just write it out. N approaching infinity, and I just distribute nq to this. So it'll be n times m plus 1 times 2m plus 1 over 6 and the 6n cubed, right? Is that okay? And the minus 2 and 2 cancel out, so it'll be n times m plus 1 to the n to the cube minus n over n to the cube. What will happen to this term when n approaches infinity? It's just going to be 0. So it's still technically down to that first term, which is n to infinity of a times 2n to the cube. Is that okay? Over 6, right? N to the cube. This one equal to 16 over 6, which is 8 over 3. So it doesn't matter if you do it left or right. If you break small enough pieces, there is no variation. There is no difference between two areas you consume from both directions. Jared, do you understand? Okay. Austin? Don't just nod. If you don't understand, ask me. Tell me where. Okay. Anthony, you got us? Okay. Daniel?
Almost.
I mean, just algebra at the end. Because all the terms are going to go to 0 except n to the q on the numerator. Which is, it doesn't matter what happened the term after that. It's pretty much take only an account into this part, this part, this part, this part, and this part. And because every term after that is going to go to 0. So I'm not going to be write out everything, but I know that it's going to be have like 2m squared plus 8n to the square plus something n. And then, but any those things that's going to go to 0 because the bottom is nq. So only thing that can match is the highest degree. The highest degree is nq on the numerator, nq on the bottom. The coefficient in the front is going to be 16 over 6. It's going to be 8 over 3. Regardless if I use right endpoint or left endpoints.
Can you scroll up a little bit?
Yep.
What's the notation for the thing all the way at the top? The funky ass numbers in.
The funky ass what?
With the numbers above and below it.
Where?
I think it's the integral sign.
This?
The top left. Yeah.
Oh, that's integral sign, yeah.
What are the numbers?
Oh, that's the upper bound and lower bound.
Where to where?
Yeah, so for area, so for you, it's kind of hard because we usually start with approximation, with right hand approximation, left hand approximation. This is the first time we start integral.
So are we still gonna learn? Like have a test on right hand and all that?
Yeah, we're gonna do that. Just unfortunately, we have to make sure that Jared had to understand. Start from like a very basic right hand approximation, left hand approximation, midpoints, and trapezoid rule. But this year is a little bit different. We start with the definition of integral. But if last year, if I did that, then I would throw off half the students. Because most people would be like, what the hell are you talking about? And I don't want to do that last year, so I choose not to teach, and that's why most of you guys come back, says, Mr. Ye, you didn't teach that question 28 on multiple choice. And guess what? That question 28 on multiple choice, if I would have taught it, everybody still get it wrong. And I'll spend 3 days on that, and people's going to be like more discouraging rather than more encouraging on the AP exam. So I'd rather choose to let go that one question last year, and this year I'm gonna choose as you have to learn this.
So the number on the bottom is
The low bound.
no. Yeah.
No, we went over through competition. We didn't go over when it's another thing.
I thought that I still don't really quite understand how the summation like as a whole works.
I'll have it.
Like if you wanted to do from like forget the infinity part for now.
Mhm.
Like if you wanted to do same one x squared from 0 to 2, let's just say only 2 rectangles. Like how can you do you understand what I'm saying? Like where I guess n would equal 2.
Mhm.
Like I'll try that.
Yeah, I don't think it's really difficult. You can do 2 rectangles or 3 rectangle or 4 rectangle. Here's an example. You can look at it. Come here. Is they just break to 5 rectangles.
Okay. Yeah, something like this. I want to understand this.
Right now, we just go directly to infinite. But you see, this is this is a right hand approximation. The problem is if you do less than certain things, you're gonna have a deviation between the maximum, which is right endpoint or left endpoint, is gonna have a deviation.
Yeah.
The only way that you can overcome that deviation is n approach infinite. If you break small enough pieces to infinite pieces, then they will eventually, it's like a squeeze theorem, kind of squeeze into a certain actual values of it. And this just plug in like say 1. So it'll be 2/5 plus 5 times 2/5, and then plug in 2, and you do the calculation, and plug in 3, do the calculation, plug in 4, and all the way to 5.
You're gonna add 5 different things.
Yeah.
So you add 5 different squares. Okay.
Yeah.
And then with infinite, you're adding infinite different squares.
Yeah, that's why it's a limit and approach infinite. So that's why you need a. So that's why when we study calculus, the first thing we had to study is limits, because limit we can assume n breaking down to infinite amount of pieces.
Can you ever that's a random question, but can you ever have a limit at 2 variables approach something like n and I don't know n and delta x? Could you ever have something like that?
I haven't seen it before, but it doesn't mean it doesn't exist, because the limit amount of math I know, it's obviously by next year this time you're gonna be already way over my maximum. So I don't want to tell you yes or no because I don't know.
Okay. So what's inherently wrong with saying limit as delta x approaches 0? Like how does that make that? How is that wrong?
It does approach 3. You're just gonna raise because
It's a different way. If delta x eventually is just,
delta x is 2 over.
So that's how it approaches 0. You use that.
but you only can do one variable at a time.
Yeah.
You cannot
can
just
do n, yeah.
you had to either choose and that's why we have a summation and we have a limits.
All right. So the reason behind that is you put delta x in terms of n, and then you use.
And because the summation can convert the I to the n's.
Yeah, I see. Because you make n turn delta x into 0.
Yeah.
Does that count?
Mm-hmm. And then that's the idea is you change from, because you have n and I, the summation of I, we can use summation formula change to n, and then we can use limit and approach infinity, and then we kind of abridge from one thing to the other thing.
Yeah, that's interesting actually.
Okay, so here's the questions. I give him 2 homework questions. One homework question, something like this. I should put one more question actually, just because I think I want you guys to get used to different things.
Yeah.
So the last question I give out is this question. It just and Matthew did this really quickly. It's just y equal to 3x squared plus 1 from 0 to 2. But I also want to challenge you for how about 1 to 3? Okay. So using definition of integral. Now, I'm not going to spend time on that because I have 8 minutes to talk about the next thing, which is your worksheet. That's a lot easier when you look at this and then look at that. So this, we're going to start with that. Is last year the question looks like this. They give you this, and they say, well, what does following means? So how about this? Before I tell you, you figure out.
Why do
I is a counting number.
why do they use I? You can do it like
Oh, I don't know. I'm that's above my pay grade. I didn't decide it to be I. I'm just a follower. I'm gonna be honest with you. So, but yeah, I don't know. I guess they should have used n, but the n, then that's gonna confuse the first n because n stands for natural number. I do know in British system they don't use I equal to 1. They actually use U equal to 1 on the bottom. So that's like when I taught IB curriculum is started at U on the bottom, and they say U equal to 1 to U when limit U approach infinity. But I don't know why they use U. So it's like really people name those shit. It's like oh, AP exam, yeah, they do use K. So can you figure out what does represent this integrals? Now, the one thing to figure out is to figure out small pieces at a time. So what is delta x? What is a plus delta xi? And what is f of x? And what is a and what is b? And if you figure out that, you can actually evaluate this ugly as summations. Should I help you or you know how to do it? Yeah, sigma summation.
Yeah.
Why is it squared?
That's what you have to figure out.
I'll
So which following represents this? So yeah, you got to figure out slowly, small piece at a time. If you learn how to deal with that, you know how to go through this whole worksheet. What is the integral of, what is the integral, what is this notation represent as a definite integral? No, 3 of n.
I thought it was solving.
I mean, you are solving for it, but indirectly, you're gonna figure out all the pieces. This is 3 over n. Good. What is a plus delta x times I? 2 plus 3 and I, right? What's the f of x? What is the low bound?
2.
No. 5.
Oh,
So that'll be integration of x squared from 2 to 5 dx. The funny thing is you can actually evaluate this. Just gonna be x3 over 3 from 5 to 2. So 125 over 3 minus 8 over 3. So that's equal to 117 over 3, I think. Is 117 over 3? No, yeah, 117 over 3. And that's equal to, I don't know, 29, 39.
39.
So it turns out this notation is totally evaluable, but you just had to understand that's a definition of integral. And that's what you were missing last year. When you guys all come back, yell at me, it's like, Mr. You did not teach that question. Now imagine I teach that to Mason or Nicholas and it's not gonna work. Now with you guys that you have a little bit higher level to think that way. I mean, Nicholas can probably think of it. I mean, probably like Mason and Norman, they will have a hard time. Or like, I don't know, Vincent is gonna be, oh.
I don't know, CA.
I miss Vincent. He's such a great kid. He's so funny.
Do you know where he goes now?
You go to UF. But he's on the PACE program though.
Is that the Santa Fe?
Yeah. But the Santa Fe is already disconnected with UF now.
Yeah.
But it's also like a second tier or third tier. They didn't actually get into actual UF.
Oh, wait, it doesn't transfer until.
It does. It give you credit, same credit, but you had to study in Santa Fe for a couple of years. So you guys gonna finish this worksheet and also finish those two problems. So if it's 1 to 3, what would be the difference though? Yeah, the 2 over n is still gonna be the same, but the a is gonna be changed to 1. So the calculation is gonna be slightly different. But yeah. Reasonable.
What's the notation with like the integral times, or integral of f of x times
D of x is small change in x. In this case, the d of x is the delta x, which is the b minus a over n.
So we're now on to BC stuff?
We have to go do a little bit of AB, just like substitution and definite integral and some kinematic. And after that, we're just gonna do area and volume, which is to, even though it's AB material, but still a lot of people struggle with disc and washer. And well, we're gonna learn shell this year.
We're gonna be in New York tomorrow. I won't be here.
Oh, okay. Where are you going to New York for?